Yeah. We'll make this pretty brief. This is going to be really high level, but JavaScript libp2p is approaching its 1.0 release. It's kind of ceremonial, and so I'd like to kind of look at some of the highlights from the past few years. So about me real quick. I'm a Ethereum core developer working on Lodestar, and we have used JavaScript. We're written in TypeScript, so we've used JavaScript libp2p extensively and started contributing back a few years ago. So our perspective is definitely coming from, very biased, we're coming from a single use case of libp2p, but Lodestar is part of ChainSafe Systems. It's a company we work for. And we use it very heavily, and we focus on performance. We have probably using it for a more performance-intensive purpose than a lot of other applications, like really sensitive timings for certain things. But the TLDR for what I'm going to talk about today is that there's been a huge amount of code change to JavaScript libp2p, and it's just way better to hack on, way better to maintain. And I'm going to be talking about it specifically from a maintenance perspective. Over the past 2 years, there's been a lot more commits than we've had in the past, and a lot of breaking changes. I think 10 breaking changes since then. So if you've been like a consumer of this product, it's been really hard to keep up with all of the different things that have been happening. It's 176 contributors. So just people kind of from everything from like drive-by contributors to people at Protocol Labs and people like me who are just using it. It's been a huge effort. So it should be happening like today. Alex, if you're listening, hit the button. So one huge awesome thing that we've done is huge modernization effort. So JavaScript libp2p is, I think, one of the first 2 implementations of libp2p. So it's had a long history. And over the long history, JavaScript as an ecosystem has evolved very significantly. And so it's a lot different than a project starting fresh, where you can kind of use the kind of up-to-date paradigms from the beginning. We have had a lot of work we've had to do to kind of move things from the old type of JavaScript, kind of Wild West JavaScript, to something that's the jQuery days to 2023. So kind of some big highlights there. ES modules moving from requiring modules to ES modules. Async await. We had a lot of callback hell. Does anyone remember that? We kind of got rid of that, and then trying to standardize the types of objects we operate on and return to be more browser native, browser compatible, rather than Node.js specific and having to add shims and polyfills everywhere. So that's really, I think, going to be really helpful for people moving forward. You don't have to be thinking in this old paradigm. Another really awesome thing, this is maybe my favorite thing that we've done. It's really helped us as maintainers, but I think it is also going to be really helpful for consumers. Moving from like just vanilla JavaScript to TypeScript. I can speak as a maintainer, like this has been kind of the single most thing that has, I guess, accelerated our development and made us a lot more confident about making breaking changes and understanding the kind of the scope of each breaking change. When you're working in vanilla JavaScript, I think it just doesn't scale as well when you have a huge project like libp2p with tens or hundreds of thousands of lines of code. Having like really strong interfaces where exactly what data types are going in and out, it's invaluable, especially in JavaScript where like everything's an object. So this is just a level of protection that we get, and it makes working within it makes maintaining the project a lot better, but it also makes consuming JS libp2p a lot better. In the old days, we had kind of handcrafted types that were like, we thought kind of, matched what we were actually implementing, but they were incomplete. They were always out of date. And now you get nice IDE auto completion out of the box, and we know when we're actually breaking something, which is huge. Another thing that we did fairly recently, we moved from having a huge sea of repositories just kind of spewed all over the place in the all over GitHub, 81 results just in the libp2p organization alone, to basically a single repository monorepo structure. This has been really great because as we've had these breaking changes, rolling out the changes across all of these repos, it's just, there's kind of a fatigue, especially as a maintainer, to like just be kind of like, did you get every repo? Did you catch every single, did you push it out to everything? Dealing with possible circular dependencies or doc updates, kind of subtle things that you have to really look at in every single repo. So moving to a single repo, I think this is going to also help with contributors because it's a single kind of one-stop shop to see everything JS libp2p related. And then kind of user-facing thing, we also actually added new features, new protocols past few years. Noise, Yamux, Gossip Sub, these are kind of older, but then some of the things more recently, we have really improved the browser connectivity story. And I think Chad's going to talk about some of that later today. So what's next? So we got, JS libp2p got together in New York a few weeks ago, and we started figuring out what we're going to be doing in like the next 6 months or so. So for kind of high-level things that we're focusing on, our documentation. So right now we have API docs for everything, which are really great, but we don't have enough like kind of top-down docs for people wanting to come in and use libp2p. So just having everything like a quick start, getting started. How do I debug JS libp2p? How do I turn on enhanced logging or tracing? Things like that. It's going to be really big to like actually sharing all of the changes that we've done with the community. Performance. So this is something that we've been wanting to do for a while, and I've been doing on like the Lodestar side. We want to be doing a lot more benchmarking and kind of comparing our performance over time so that we know when we're actually regressing or how much we're regressing. There's not really hasn't been much visibility into that in the past. And kind of along with that, observability. So this is something that we've done really well in Lodestar. We run a fleet of nodes in production. We have a product that we're running, and we have extensive use of metrics to show everything from how much memory we're using at any given time to how many messages we're getting over the wire. And so one thing that we want to do with JavaScript libp2p is bring that kind of idea, bring it here. So we're wanting to run like some IPFS nodes or Helia nodes, which uses JS libp2p. We're wanting to deploy some DHT bootstrapper nodes and actually get like data from real world usage of JS libp2p, because some of the data you get there, it's really hard to actually recreate that on like a end-to-end test or a smaller scale, a simulation test. You can't really get the same data that you get actually in the real world. So we're going to be deploying a fleet that we can actually use and push feature branches to, and push the latest RC to, and kind of see how it's performing in the real world. And then of course we aren't forgetting the new protocols and more connectivity, more features. So a lot of this has been maintenance focused, but we do need to actually keep on pushing new features for folks. So we're looking at Quick. How do we get Quick in, even though Quick is not part of Node.js? So we're looking into that. We're wanting to also make browser connectivity even better. So we've got some ideas more focused on the IPFS use case, but yeah, it applies here too. So that's it. Thanks.
Thank you, Cayman. That's awesome. Well, yeah, we'll take maybe one question, and then we'll let Wonderton come up. I was curious to hear what you think is the path to getting quick in Node.js. Is that like a native implementation? Like, on what layer does that happen, in your
Yeah.
opinion?
So I think there's two paths, and we're probably going to explore both of the paths. So one path is trying to like find a fully featured quick implementation. So quick is already shipped in Rust libp2p. See if we can like bundle that as WASM and just kind of jam it in and make it work. That's kind of the faster, hopefully faster path. And then the other path we're exploring is we're working with the Node.js core contributors to try to push forward the Node native quick implementation. So working with those guys, yeah.
Yeah, and just to add to that, there's actually just a third option as well. There is some like a existing web transport implementation that we were exploring as well. There are some, I guess, quirks to that implementation, but that is also it built on C++ bindings for Quick as well. So that's something we could also explore.